So in the last video, we built this code where we're able to parse an expression, compute the result, and then output that result to the screen. I'm going to refresh this. The only thing you should see is this name change right now because it's going to change to what I want to talk about during this video, which is exceptions. And so here you can see exceptions, as that's what it's being called. And this is going to allow us to address this issue that we have here. What if we get to a point where I don't have 3 parts? So I'm expecting 3 parts, but what you fed in isn't 3 parts. So right now, for example, if I were to feed in something that looks like this, really only has 2 parts. And so if I feed that in, my code is going to break because on line 29, which is right here, there is no part number 2. There's only 2 parts. There's a 0 part and a 1 part, but there is no num2. It doesn't know what that means. There's a couple of different ways that we can handle this. So I'm going to show you the first couple of ways, and then we're going to introduce exceptions. So one way is I can say num1 is equal to null, num2 is equal to null, and operator is equal to null. And then after I parse the parts, I can start to add code in here like this. I can say if count of parts is greater than 0, that means it has at least 1 part. I can say num1 is equal to parts 1. And then I can say similar code. So if count of parts is greater than 1, I know it has at least 2 parts. I can say the operator is equal to parts 2, the second element. And then I can do the similar thing for the last one. So if it's greater than 2, it means it has 3 parts, and I can say that the last number is equal to that. So now I have the numbers. What I can do now is, instead of using these, I can say num1, and this will be, I guess, num2, and I have operator. So that's certainly one way to handle this, and it's not a bad way. This handles the case where no matter what I feed it, if I get at least 1 part, it's going to set num1 equal to that. So get rid of this. Let's run this and see what we get now. And it has an issue again because it says, well, the operator B must be of type float, and we gave it a null. So let's go back through here. And I could initialize these to some numbers, but instead of doing that, let's go ahead and see what we have. So I'm having these here. What I can end up doing here now is I can write code like this. So if is null, num1 or num2, or is null the operator, then I can do something else and I can exit early. So maybe I say invalid expression. I show the expression that I was given, and then I want to exit this piece of code early. So I can just say exit 1 and then I'm done. So what exit is another keyword or command. This command means that I'm going to actually leave my function that I'm running early. So if I run this now, let's see what I get. I see invalid expression. It shows the expression, and then we left early. So this is certainly one way to handle this, right? So down here where I parse expression, I'm guarding against whether I have the number of parts that I need to fill out any particular value. 1 part, 2 parts, 3 parts. If I don't have them, I have these initialized to null, and I return that in my array. And these are all null. So up here then, this might be null, or that might be null, or this might be null. And if any one of them are null, then I'm going to exit early by echoing out invalid expression, and then I'm done. Now that is absolutely one way, and that's a valid way of handling this. I'm not sure if I would do it like this or not yet, but there's probably a little bit cleaner way that's built into the PH language that we can use. So I'm going to go ahead and let's get rid of this code that we just stubbed in. Okay, so that's there. And I'm going to get rid of this code here that we stubbed in. And let's just get it back to the point where we're functioning. So I'm going to put an expression that should work. And down here, we'll return the parts itself. And I'm going to put some code in here in a second. We don't need these initial values anymore. So all we're doing is we're exploding this thing apart. We're going to inspect it in a little bit to see what we have. So I'm going to add some code in here in just a bit. So we're just trying to get back to working. And I'm going to allow PHP to automatically split this thing into variables for me. So this is going to be num1 operator and num2. So if everything's functioning, I don't need this anymore. All right, let's just go over the changes real quick. So parse expression, let's look at that first. We're still exploding it based on space, and we're just going to directly return the parts array. If you remember right, this is going to return an array of 3 things, a 10, a plus, and a 3. So PHP has the ability, it knows that it's returning an array, and you have 3 variables. If you got 3 elements in your array, it'll automatically assign these variable names, the first element, the second element, and the third element. This now should function. So I'm going to go ahead and run this. Let's make sure we're at a valid state. So we are. So let's go back to, hey, how do we handle this? So if I run this again, I'm going to get a different thing. It says array key 2 on line number 7. So it's saying this thing is invalid because I only got 2 parts. And you're trying to split this back into something that should be 3 parts. So I can detect if I don't have enough parts, right? So I can count the parts. So if the parts is equal to 3, this is the valid case. I want to return these parts directly. Otherwise, if I get down here, I'm going to throw an exception. We're going to throw a new exception, and this exception is going to be an invalid expression exception. This is the new syntax right here. Parse expression, I explode it out. If I get 3 parts, which is exactly what I think it should be. What is complaint? Oh, I got the parentheses on the wrong side. Parentheses here, get rid of that. That makes sense. If I count the number of parts and I get 3, I have the number of parts I'm expecting. So I just return exactly what I split out. So I get those 3 parts. Otherwise, I'm going to throw a new exception. And inside this exception, I can put a message in here. So now let's just go ahead and run this again. Let's see what happens at this point. Now you can see I'm getting this uncaught exception. And it says the exception name is invalid expression. That is my exception that I just threw here. So what I want to do up here now is we're going to try to catch this exception. And that's why it's saying uncaught. So there is some additional syntax for exceptions. There's a try part, and we're going to put our code inside the try part. There's a catch part, and we're going to catch the exception. And then there's some code that you can execute if there was an exception that was thrown. And if the exception is thrown, we're going to exit early like we did before. Now what happens is down here, if I don't get 3 parts, I'm going to throw this exception. When you throw an exception, if it's inside of a try block, it'll come down and it'll run the code that's in the catch part, this catch block. If this executes and there's no exception, it'll just come in here, run this code, and then it's going to continue on with the rest of your code base. If I change this back to normal, we expect this to function as normal, and indeed it does. All right, so now if I try this again with an invalid expression, so I take out that operator in the middle, let's run it again, and I get this is an invalid expression. Now, if I put it with maybe, so right now there's 1 space. What if I add 2 spaces? What's going to happen next? So it's going to split on spaces. So I'm going to get a 10. After that space, I'm going to get something, which is going to be a null. And then I'm going to get a 3. So I will get 3 parts, but the middle piece, which is the operator piece, is not going to be one of our supported operators. So it's not going to be a plus, a minus, a multiply, or a divide. So let's see what we get. It's kind of what we expected. So unsupported operation, it's trying to print it here, but there's nothing to print, which is fine. So at this point, I think we have a way that we're guarding against unsupported or exceptional cases. So we can use a try catch and we can throw exceptions. So those are the new parts in this. We talked about exception handling. One way was we actually guarded against everything, and I was very pedantic about making sure there was only 1. If there was 1 element, I set num1. If there was 2 elements, I set the operator in num1, and that certainly is a valid way. This is probably a little bit better as far as coding goes. So if I get an expression that doesn't have the required number of parts, I throw an exception, and then outside of that, I catch the exception. So I have a try catch block. So, and this is probably the better way of managing that exceptional case where you don't really have a valid expression.